Hello everyone and welcome back. So whenever we start doing R&Ds, we generally are required to do multiple widgets and test various settings and things like that, and find out what works best, and hopefully take a note of the sim time and things like that, so we can analyze this data and understand properly what to do with these settings. Now with DOPS or with Bullet, there's few major settings that I always like to test. The first one is the DOP substeps, and this is very important, especially if you have animation or input that has subframes in between. So if you have a character, for example, that has deformation, you are able to build interpolated subframes data for DOPs to use. If your data if the input data, for example, has changing topology between frames, that it's not going to be possible to generate properly interpolated data in SOPs to feed into DOPs. So there is no point in doing extra DOP substeps. And the main thing is, if you have fast moving characters and things like that, Bullet substeps will not solve any of this. You always have to increase the substeps at the DOP level, which will reevaluate everything in DOPS multiple times. With Bullet, it only reevaluates the substeps in Bullet, only reevaluates the actual collision solving and interpolation and constraints, and it doesn't work with anything else. So it's very important to understand these two and how they affect the sim. And then if you want to fine-tune the sim time and things like that, it would be nice to start with a Bullet substep and constraint substep of 5.5, and then go higher to see how that affects the result and which look you like the most. For example, you can get a decent result and a nice looking result with certain breaking threshold in the constraint network, with a Bullet substep and constraint substep of 2020. If you increase those values to 60, the breaking rules will not work exactly the same, so you will get a different look, a different sim. And then the other very important thing is to pipeline all this, so I don't want to have to worry about the files. I want to have files for each of these benchmarks, okay, and then I want to have the sim time also information embedded in, which is something that you can only embed afterwards, and we can only export JPEGs from Houdini, and I want this process or this small pipeline to generate an MOV for me to look at. So this is an example of how one of my wedges looks like, and here I'm testing constraint steps, Bullet steps, and they both start at 10, and then they're gonna change to here I'm testing the constraint only. So here you can see the constraint substeps is changing. It's 30, and that's reflected in the file name. There's also a sequence of JPEGs as an OpenGL render that was generated, and inside each one of these guys there is a HIP file. So in case I destroyed this or I didn't know where it came from, I always have a backup for that file. And this is testing the DOP steps, the DOP substep settings, and you can see we get different results, and this is the MOV for that. So let's take a look. I'm not gonna recreate this from scratch. I will share the file with you guys. So basically we have a cam preview called in this case, and then I have text parented to it, so an actual geometry node. And how I did this is by simply creating camera. We can look at the camera first, and then we'll create a geometry node. I'm gonna parent this node. Let me change this to light, and I'm gonna dive inside and create a font node and say Rebel Way, and let's go up and make sure this text is somewhere in the frame. Okay, something like that. So let's take a look at the camera, and I'm going to scale it and position it so that it's correct from this angle. and because it's parented to the screen, to the camera, once we start moving the camera, the text will always stay in the same position. So that's how these guys are set up. Okay, and then inside this there's multiple font nodes. Each is set up to point to a specific thing. This guy here, the nodes, you can see there I'm channel referencing various settings from the DOP, and you can add as many as you want. Any valuable inputs that you like, you can simply add that here and then link it to the where it should locate that value from. The what is this setting? This is description that we can put, I believe, somewhere. Yeah, so the description is here. This is the text I'm gonna embed here, and we can position these guys any way we want. And then the scene name is referencing the HIP file, and then the FPS is the frame rate. Cool. So that's pretty much it. The settings are coming from there, and then let's see. Let me check one more thing. Okay, so and then what I have is inside the out context, I have these two nodes. I have a write cache, and this is what's going to write the files to disk. Okay, so I'm going to cache the sim. The SOP path for the cache is this. If I go here, this is what I'm writing. I'm writing the point cloud, or the transform points. Okay, and then I'm storing that to disk, and as you can see here, the file name is driven by another attribute that's going to change every time the wedge increments, and then this is going to generate the OpenGL preview. So this is all scripted so that the file gets written under the correct name based on the wedge setting. And then I have this out path, which runs a sorry, let me check. Yeah, it runs a Python script that I will give you guys that will generate an MOV file, as well as add the timestamp. So the timestamp is actually a Python script that I wrote that checks the creation time of the first and last frame and computes the number of seconds, and that's what we're going to embed on top. And this is a Unix command that will copy the HIP file to the location of the JPEGs. And I think that's pretty much it. And then the last part is the wedge. So here I'm dragging the gen sequence here. Okay, and then I'm setting the number of wedges to 2, and what I'm doing is I'm changing this attribute. See here, this is the substep, the DOP substep value, and I'm changing it from 1 to 8, and the number of substeps is 8 basically. So I test with 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it's gonna go through and change this value here, and that's gonna drive pretty much everything else that is connected to these nodes. So I think it will be really simple for you guys to take a look at this, and you can copy this platform and just update this, or you can rename it obviously, and just update this graph and make sure that you have a 2 cache node, and then this node will import. No, that's it. All you have to do is this node, and then everything else should work pretty much. And whenever I have a project where I'm testing a new techniques, I would do a lot of small R&Ds like this and have the wedge settings, and then I would figure out what kind of settings I would be using, or what would be a reasonable setting. For example, the new Valium solver, I'll probably be doing a lot of tests like this to understand the settings and how they would work. And I think that's pretty much it. Thank you guys for watching, and see you in a bit. Bye bye.